Good day to everyone. This is Professor Roger Flores of the Central Mindanao University, an associate professor of the Department of Electrical Engineering. Today we are going to discuss how you are going to perform or do electrical design and estimate of a residential building. So this will be our first requirement to have an electrical design of this residential building, simple residential building. Okay, so to start with, we have this floor plan. Okay, so what you're going to do is, so you must know, or we must have to provide a floor plan, and this floor plan will be where we are going to do our electrical layout. No? So in this floor plan, it is necessary to provide the dimension. No? The dimension of the floor plan. What is the purpose of having this dimension? Of course, first and foremost, we are going to estimate the quantity of our materials like wires. Okay, so how long, the quantity of what is, or how many boxes, how many rolls of this conductor, for example, so that we will be able to estimate the quantity. Then we must know what is the dimension of the area or a given room or the area of our residential building. Okay, aside from that, then we should know the name, or what we call this one, the purpose of that area. No? So like for example here, this is the living room. Okay, so this is the living room. This area here, nearer to the entrance door here. So we have this living room. Okay, so there is a problem in advance. I will tell you that there is a problem of, of this building, of this residential building that we designed here, because we don't have an exit door. That supposedly, according to the building code, if we have entrance door, then we should have an entrance door also. Anyway, so we just take note that one, that we must have our exit door. Okay. So this area here is our dining, or what we call as the dining area. This is the comfort room here. Okay, so this is our comfort room, and we have another room here. It is our bathroom. Now I decided to separate the comfort room and the bathroom because there might be some problem of the occupant, no, for the occupant, that there might be a time that two users of these restrooms, no, for comfort room and the bathroom. Okay, so that the user we can do what they want, no, at a certain period of time. Then we have a separate comfort room and the bathroom. This area here is our kitchen. Okay, so we have this table here, tiled table. We have here our lavatory. Okay, so this area here is the kitchen. Then we have two bedrooms. Okay, we have this bedroom here, and then it has its own closet, built-in closet. Then, okay, so we have also this master's bedroom. Okay, this master's bedroom has its own closet also, no? We have a closet. Okay, this is our bedrooms. Okay, so aside from this label, then we have these dimensions. Okay, now for your label, if we are going to label these bedrooms, as much as possible, write the labels here at the side, no, not in the center. Okay, so like for example, this word bedroom here, or master's bedroom, put this labels here at the side, no, at the side, so that later on, if you're going to make an electrical layout, then it will not cross, para hindi to maging sagabal sa design natin. Okay, so we have this one. This is a simple, no? A simple residential house. The only thing is that we don't have an exit door. And aside from that, it is necessary also, no, that aside from the labels, we should know the opening of the doors. Okay, so we should know the opening of the doors. Like for example here sa ating entrance, no. So we should know what is the direction of the opening of this door, so that we will be able to place our switches correctly, or in a proper place, no. So like for example, our comfort room, we have also this. This is the opening of the door. We have that one. For our bedrooms, this is the opening of the door. So that, as I've said, so that we will know where to place our switches. No? Because later on, we will know that our switches should not be placed at the back of the doors. Okay. Aside from that, also we have to know the windows. Okay, where these windows, no? So, like for example, this one, so we should know that this is our windows. We have here in this master's bedroom, we have two sides windows here, and we have another one here, and this one. Okay, our windows. Okay, so why is that this is necessary? Because that sometimes there might be some erroneous placement of our outlet, okay, or our switches maybe. Okay, so this is more or less the important thing in the floor plan. Okay, so next thing that you are going to do, try to locate first where we are going to place our panel board. So in our design, okay, this is the we have here the panel board. Okay, for that. So we have here our panel board here. This rectangular in shape. Then it is color diagonal with blue. Okay, so one thing that which is very important in locating our panel board is that it should be placed facing um, to the post, or the supply, no, power supply from the distribution utility. So I place this one here because I assume that the power supply from the distribution utility will be somewhere in this side here. Okay, so next is you are going to draw our lamps, no? The location of our lamps. Okay, so this rectangular with the circle inside is the symbol of a fluorescent lamp. Okay, so this is a fluorescent lamp. I have one fluorescent lamp in our living room, one fluorescent lamp in this dining area, one fluorescent lamp in these bedrooms, and one fluorescent lamp in this master's bedroom. So I have incandescent or lead lamps here. So we have these surface types lamps, no? So we have here, no? We have surface types lamps, one in the surface, in the entrance. Okay, we have all these lamps. One of the problem of my design here is I forgot to place or implement perimeter lightings now outside. So if you have this residential building, try to implement perimeter lightings in our design, in your design. Okay, so anyway, that is anyway optional, but it is necessary for lamp outside, no? Okay, so put a perimeter lighting here anyway. So we have that. Next thing that you're going to do is connect all the lamps in a branch circuit. So indicating branch circuit C1. So your C1 here indicates the branch circuit 1. So therefore your branch circuit 1 is for lighting system. No? So it connects this fluorescent and this surface type lamps with all these things here. So as you can see, all my lamps here are connected only in one branch circuit. Okay, we have only one branch circuit C1, but it is suggested that more or less in a household, in a residential house, more or less we have to implement more than one or two or more branch circuit for the lightings or the lamps. Why? Because it is necessary that, for example, if you might have problems in this branch circuit one, so whole building will now be dark or walang ilaw because you have only one branch circuit. So that is why it is suggested that your lamps should be divided into two or more branch circuit. But anyway, this is just a small or a simple residential house, so you have only one branch circuit to be economical also. No? So these how many lamps? One, two, three, four, five, six, seven, eight. 8 lamps were connected or are connected in one branch circuit. By the way, this is the symbol of a branch circuit, and every time you're going to draw a branch circuit, then try to locate your branch circuit facing to your panel boards. Okay, facing to your panel boards. It is just a suggestion anyway. Okay, next, try to determine now your switches. No, so as you can see here, we have these different switches. Okay, so for me, every time I have to make an electrical plan, I should have to implement this symbol here of a switch. This is something like a capital letter T. Okay, so that is a symbol of my switch here. So we have these switches, and we have these switches, and we have these switches. So as you can see, we have these two types of switches that I used here. So this one, we have this is1, we have this is1, is1, we have this is1, is1, and I have is2 here. Or we have is2. Oh. So dalawa yung is2 natin. So anong ibig sabihin ng is1 at saka is2? Or some electrical engineers will just write here S, or not putting it 1, but anyway they are just the same. Simple, just simply S or is 1. Okay? Ibig sabihin you have only one single pole switch in a one gang plate, no? So, or in a plate. So that is 1. So if we have this is 2, this means to say that we have two single pole switches. Two single pole switches gang in one plate. That is what is 2 means, no? So because as you can see here, this lamp in the kitchen area and this fluorescent lamp in the dining area is only are controlled in one location. So this is 2. So they are controlled in one location, but individual switches in one location. So that is why it is 2, meaning you have two single pole switch gang in one plate. Okay, it is different from is1 because you have only one single pole switch. Okay, so as you can see here, our switches is located in the strategic areas, no? And it is, for example, in this area here, in the entrance door, it should be located at the side so that you will be able to switch it on easily. Okay, so do not place your switches in where it is maybe at the back of the door, because it's very hard to, maybe it's hard to switch on our lamps if it is at the back of your doors. Okay, so that is the reason why, as I've said a while ago, that we should know what is the direction or the opening of your doors. Okay, so we have 1, 2, 3, 4. We have 4 is 1 and is ones, and then we have 2 is 2 or is twos. Okay, so that is our. This is the electrical layout, our lamps, no, and lamp layout. Okay, lamp lighting or lighting layout. Okay, so the most important in the lighting layouts that we will know where to place our lamps and what kind of lamp that you're going to implement. We will know where to locate our switches, and then what are the switches that we're going to do or to know or to use. Okay, so as I've said a while ago that the lacking part of my design here is the perimeter lightings. Okay, so anyway, in your design, try to implement perimeter lamps. Okay, next thing that we are going to do is our try to make a layout for the convenience outlet or special outlets. No, so as you can see here, I have several convenience outlet, and this is duplex, and this is the symbol of a duplex convenience outlet. So to make it good to look at, then this is a simple circle. Anyway, I'm sorry for this drawing here because it becomes oblong. But anyway, it should be circle, and we have two parallel lines facing to the wall. Okay, two parallel lines facing to the wall. Then what does this two parallel lines means? Then it means that this is a duplex convenience outlet. So a convenience outlet having two opening or outlets, no, two outlets, so that we can use at least two appliances at the same time in this outlet, no. So we have here, so in our master's bedroom, more or less, we have these two outlets here, two duplex convenience outlet here. We have in the bedrooms, we have here. We have in the kitchen, we have one convenience outlet. In the living room, you have two convenience outlets, and I mean three. No, we have another one here. And this dining area, more or less, we have at least two duplex convenience outlets. Okay, so as you can see here, as much as possible, uh, if there is a chance, then try to locate your convenience outlet or back to back. For example, these two, no? Why is that we will be doing this one, or it is advised, so that we'll be able to more or less might affect the economy of our design, no? So more or less siguro hindi masyadong marami yung wire na magagamit natin. So that is why we have to locate as much as possible. Try to locate our convenience outlet back to back each other. Okay, so for example, if you are planning to have singplex or single outlet, okay, a single convenience outlet, so just try to use only one line here inside this circle or as in the symbol of your the convenience outlet. So only one. So if you are planning to have three, so three convenience outlets, then it is advised here to have a three lines parallel, so that we will know how many outlets for this specific or how many outlets for this specific convenience outlet here. Okay, as you can see, one of our outlets here is this special type. and this is we use this symbol. Then this is used for the range outlet, electric range, no? So it is found, or it is located in the kitchen area. So how you're going to, what symbol that you are going to use for this range outlet? Try to have this simple, like convenience outlet, but try to write R, the here in this portion or anywhere in the side, no? So that you will know that this outlet is a special outlet intended only for this cooking device or an electric range here, because all electric ranges should have a separate branch circuit. Okay, so again, next thing that you're going to do is you have to connect all these convenience outlet and have its own branch circuit. And another thing, another suggestion, similar to your lamp branch circuit or lighting branch circuit, supposedly it is advisable that you have to divide this number of convenience outlet into two or more branch circuit. Same reason that we have. If there might be some problem in any of the branch circuit, we have still another branch circuit that can be used for anywhere in the building. Okay, so this is one of the things that I just want to emphasize here. But anyway, in my design here, I have only one branch circuit, and it is C2 here. So our C2 includes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have this 10 duplex convenience outlet. And we have this range outlet. We have this, as I've said a while ago, it should be special outlet, special type outlet. This is for cooking device, an electric range, so it should have a separate branch circuit. So similar suggestions as the lamp branch circuit, your branch circuit number is or should be facing to or face to the panel board that we have. Okay, so this is as simple as this in making electrical design. In making an electrical design. Okay, so we have this outlet, no, the convenience outlet design. Okay, so most of the time, electrical engineers will just combine the lighting at the same time, the convenience, the duplex, simplex, or the special outlet in one floor plan only. But I should have to suggest that you have to separate the floor plan or the layout for the convenience outlets, special outlets, and separate also the uh, the electrical layout for the lamp or the lighting outlet. Lighting outlet, no, lighting layout. Why? Because it will become crowded, and the electricians that might install our plan might will feel harder to understand the connections because it will create crossing of these wires here. By the way, the power that will be distributed in this convenience outlet here will be connected, or this convenience outlets here or this special outlet will be connected using the broken line. Okay, so previously in our lamp, no, it is our lamps are connected in a solid line, no, solid line. So our convenience outlets here are connected using this broken line, and it passes all throughout in the wall side, so that it will have, it looks like okay. So it is nice to see our design because it is not crowded, dirty design. Also, it is not crowded design. So it is Anyway, it is just a matter of connecting all these convenience outlets here. But in the actual installations, of course, it will just cross here in this flooring, in the wall, or in the ceiling. No? So it's up to the contractor, or it's up to the electricians, no, where to uh, where to implement, where to place these wirings. No? So the next thing that you are going to do here is the schedule of loads. Okay. So what is this schedule of loads? It is just a summary of the devices that we use in our design. No? So we have these different columns. So this is our schedule of loads. You have the first column here is the circuit number. The second column is the description of the individual branch circuit. Then the number of outlets, the third column here, number of outlets, the number of lamps, number of convenience outlets, number of our special outlets. Okay, so I include also here different types of switches so that we will be able to summarize how many is one, how many is two, how many is three if there is, then so on and so forth. No? So that it is easier now to estimate the quantity of the devices that we are going to provide. So the next column here is our power in volt ampere. No? So we have, since we have based on our lighting layout, we have 18 outlets, 8 outlets. So 8 outlets that we have. So that is our C1. So according to the Philippine Electrical Code, that for every lamp outlet, remember this one, for every lamp outlet, you have to assign 100 watts. Okay, so that is why we have this 800. We have 8 outlets, 100 watts per outlet. Then we have these 8 outlets. Remember this one. Okay, so every lamp outlet, it is considered as 100 watts. Then we might ask, now, what if this time we will be using LED lamps or light emitting diode lamps? And the watt rating of these LED lamps is very small. So even though the power of these LED lamps is very small, but until now, our Philippine Electrical Code still provides that our lamp outlet, should have 100 watts per outlet. So, okay, that is why we have this 800 volt ampere. Okay, so volt ampere or watts, so do not be confused with that. Okay, so for this convenience outlet, if you can recall, we counted that one in our convenience outlet layout. Then we said that we have 10, but all these 10 convenience outlet is duplex. So that is why we have that 10 times 2, because that is duplex. So we have these 20 outlets. Then according to the Philippine Electrical Code, for every outlet, convenience outlet that we have, every outlet, it should be allocated with 180 watts or 180 volt ampere. So we have this 20. Actually we have 10. Okay, 10, then times 2 because this is duplex. Then 20 times 180 80 volt amperes. Then we have this 3,600 volt amperes. Okay, for the range outlet, uh, uh, it depends, no? It depends on the watt or the volt ampere rating of your range, but it is proper according to the Philippine Electrical Code to allocate 6,400 volt amperes for the range outlet, electric range outlet. So if you're going to sum up this 800, 3,600, 6,400, then it has a total of 10,800 volt amperes. Okay, so the next column here is our voltage. No? So try to use this nominal terminal voltage of 230 volts. Okay, So this is single phase. So we have the 230 volt our potential here, no? Okay, so according to our formula to determine current, now we have to determine current here so that we'll be able to assign or allocate our breaker setting or protect the rating of our protective devices. No? So it is rated, our conductor and the breaker setting is rated in uh, the current, the ampere current, no? So we should have to determine the current. Okay. So for the lighting, we have this 800 volt ampere divided by the voltage 230 because power or the apparent power is voltage times current. So to determine the current, it is equal to power divided by the voltage. So we have 800 divided by 230 volts. So more or less that is equal to 347 amperes. Okay. Similarly, we have this 3600 divided by 230. Our current here is 15.65. So for our electric range 6400, we have this divided by 230. More or less, we have this 27.83. So our total current is 10,800 divided by 230. That is equal to 46.96. Okay, the next column here is our breaker setting. Breaker, as we know, it is the protective device used to protect individual branch circuits, no? Okay, since we have this 3.47, ang smallest breaker setting natin is 15 ampere. So this is smallest, no? So that is why even though this is only 3.47, our breaker setting is 15. So for the convenience outlet, we have this 15.65. So we use the breaker setting to 20 amperes, ampere trip or amperes breaker setting. Why we will not use 15.65? Because that is very it is already more than 15 amperes, no? So you cannot use this 16.65 um, or 15, no, breaker setting. Okay, so and another aside from that, no, even though if, for example, our current here is less than 15, but in the Philippine Electrical Code, it is provided there that the smallest, no, the smallest breaker setting of our convenience outlets should be 20, or it should be protected by 20 ampere rating of the breaker, no, the circuit breaker. So, for example, if your result here, your current here is only 10, so even though it is 10, but you should have to use the smallest breaker setting for the convenience outlet, which is 20. So that is the smallest breaker setting for the convenience outlet, 20. So that's it, no? For the electric range, no? You cannot use 20 here because we have 27.83. You cannot use also 30 amperes. Why? Because one thing that is important in assigning a breaker protection, no? So, or the current protection is that your breaker should not be used more than 80% of its rated load. Okay, so if you're going to use 30, for example, more or less it is less than 27.83, the 80%, no? 80% of the capacity of this 30 ampere breaker is less than 27. So you cannot use this 30. So maybe what will be the next breaker setting? It is 40. 40 amperes. Then for the 40 ampere circuit breaker, so you can use this. That is the next breaker setting capacity of to protect our electric range. No? So that is why we will use 40 other than 30 ampere. So for our protection for the main, no, for the main breaker, so we have this 46.96 or total current. So that is we have 60 amperes. So again, next to 40 amperes, we have 50, we have 55. But to make sure that the whole circuit, the whole building that we have is uh, correctly protected. Okay, so we have to use this next breaker setting of 60 amperes. Okay, so next is you have to assign our conductor sizes. So take note that the conductor size should match to the breaker setting. Okay, so like for example, if we have a breaker setting is 15 amperes, then it matches to 2.0 mm squared conductor size. Okay, so if we have this 20 ampere breaker setting, it matches to 3.5 mm squared. If we have this 40 amperes circuit breaker, we have this 8.0 uh, mm squared. So for the 60 amperes circuit breaker, the size that matches this 60 ampere is 22.0 mm squared. And the last column here of our schedule of loads is our conduit sizes. So this time that flexible hose is not anymore advisable because it is easy, it is very easy, madali lang yung masira. It could be will become brittle if it is exposed to different weather. Then it will become brittle, and then it will become easily broken, no? Or even if it is concealed in a floor or in a wall, then if during piling of this concrete slabs, flooring, then it is very to, easier to be damaged. No? So this time, if you will be using this uh, raceways, for example, then try to use this PVC conduit, at least PVC conduit. Or you can use this EMT, this electric metallic conduit or tubing or tube, electrical or electric metal tube or tubing or EMT. Okay, so you can use PVC or you can use EMT. So I assigned here the size of 15 mm diameter of your tubing. Okay, so we have this total power. You have this computation here below the schedule of loads. No? So you have here the total power of 10,800 as we computed here. So show your computations analysis. So we have this 10,800 divided by 230. Then we have this 46.96. And then try to assign now the size of your conductor. Try to use two pieces of 22 mm squared TW copper wire. Or this time at HHN is highly advisable here. Okay, so your circuit breaker for the main is 60 ampere, or you can use 60 ampere fuse if you will be using fuse. Okay, so in the computation also of your total current to determine your total current here, you can also use the demand factor. So you can use 80% demand factor for a greater power. For example, you can use 140%. So what does this mean? You have for the first 10,000, 100%. Then the remaining power, multiply it by 40%, and that is your demand factor. 100% for first 10,000 volt amperes, and then 40% of the remaining power. Okay, so next thing that you're going to do is try to draw your riser diagram. Actually, riser diagram is not so you cannot appreciate this more if you will be designing residential or a small building. But of course, in a high-rise building, you can appreciate the importance of this riser diagram, because this is where you can find uh, the location of the panel boards for these circuits for a specific floor for this high-rise building. No? So, for example, this panel board, this NDP, the main distribution panel, the sub feeder, you can find this in a third floor, in the fourth floor, and so on and so forth. So, it is easier to locate all these panel boards if we have this riser diagram. But anyway, I include this one here, even though we are just designing this residential building, because later on you can use the purpose of having this riser diagram. So what are the things that includes riser diagram? Like the breaker setting, okay, for lamps, for example, C1, we have 15 amperes. You have for C3, we have 40 amperes. This is for your electric range. And for your C2, we have the 20 amperes. Okay, so you will assign also your size of your conductor with the type of the conductor that you're going to use. So that is for C1, we have that 2.0 mm squared TW, and so on and so forth. No? So just refer to your schedule loads, then you can label all these things here. Okay, so next is you have to provide single line diagram. Okay, so for the single line diagram here, so you have the service entrance. This is the symbol of the single phase service entrance. This is the symbol of your energy meter or the kilowatt hour meter here. Then this is the main breaker. You have the broad circuit breaker here for C1, C2 here, 20 ampere, C3. So we have another one here, which is your spare. Do not forget to have this spare. Why? Because according to the Philippine Electrical Code, that every time you have your electrical circuit installation, you must have to assign at least one spare. So your spare don't have any rating here. Okay, so next thing which is very important in the electrical design or plan is the site map, no? So it is just as simple as this, no? So your site map is will include the north pointing symbol here, so that you will be able to orient the position of your design. So this means to say that this is pointing north. So do not forget this one. And the road, okay, this is the highway or even just a barangay road or any road or streets, no? So try to draw the road or streets of your design. Then in the site map also, try to locate the nearest landmarks, the nearest landmark, for example. No? So one of the example of the landmark is the churches, schools, plaza. Okay, so those are some of the landmarks, the area landmarks of the location or the site map. So this is the highway. This is going to Malaybalay. This is going to Valencia. By the way, the location of the project, this residential building is in Bangkod, Porok 5 Bangkod, Malaybalay City. Okay, so you must have to specify your name here, the owner, and the address. And then, this is the landmarks that I can provide. The Church of the Iglesia ni Cristo, somewhere in Porok 5 Bangkod. Okay, so we have these small streets here, and then this is the location. Okay, as labeled, this is the site. Okay, aside from indicating this area, then it should specify the distance from the road or from the highway. So in other words, this site here is more or less equal to or have a distance of 100 meters from the highway. Okay, so these are some of the important items that you can find in the site map. Okay, so as I've said, ulitin ko lang na kailangan natin ng mga landmarks. O, ano po yung mga example ng mga landmarks? It is maybe a church, school, a barangay hall, or a barangay sites, no? Or like for example, a river. So those are some of the landmarks that we can provide, no? So churches, that is why I have here the Church of the Iglesia ni Cristo somewhere in Poroxico, Bamban. Okay, so I think these are some of the important items, no? And another important item here is the legend and the symbols that we are going to use in our design. So as we said here, we use this symbol as our symbol for the panel board or the panel, the breaker panel. Then we have the symbol of the fluorescent lamps, the symbol of the compact fluorescent lamp or the CFL, or maybe this time you can use LED lamps, no? Or the light emitting diode lamps. Then the service entrance is one here is the single pole switch. Is two is your two single pole switch in gang in one plate. Okay, so this is the symbol of is two single pole switch gang in one plate. And this is the symbol of the duplex convenience outlet. This is the symbol of the special outlet, which is for range outlet or range electric range. And this is the symbol of the circuit home run. This is the symbol of the kilowatt hour meter or the energy meter here, or the circuit breaker. That is the symbol of the circuit breaker. And the conductors connecting for switches and the conductors connecting power supply of the convenience outlets or any other devices that you are going to use that you used in your design should be all the symbols that you use. For example, other lamps, no? Other lamps, for example, if you are using strip light lamps, no? So try to make a symbol out of it, no? Then try to specify it here. So whatever symbol that you use in your design, so try to specify it here in your legends and symbol. By the way, we have another item which is very necessary here is the notes and specifications. So I was not able to prepare a notes and specifications. So what are the things that includes the notes specification is one thing there is that it will say all works herein shall comply all the requirements of the latest edition of the Philippine Electrical Code, the latest building code, or any other rules and regulations of the local distribution utilities. Okay, so that is one. And maybe other notes and specification is all workmanship here should be supervised by an electrical engineer or must have done by a registered, duly registered master electrician, so on and so forth. Or the specifications of your lamps, specifications of your outlets, specification of the devices that we try to use. Try to write it in these notes and specifications. That is the only item that is lacking here in my design. Okay, so I think that is the last part of our discussion, and I hope that you learned something, and I hope that you try to continue studying and designing, no? Because the electrical plan is one of the output of an electrical engineer. But take note, if you are still registered electrical engineer, you cannot sign any electrical plan. Electrical plan is or should be signed by a professional electrical engineer. Registered electrical engineer could not or cannot sign any plan, electrical plan. Okay? But of course we can make our own plan. But when it comes to documentation and legal papers that we're going to submit in the OBO, Office of the Building Officials, then it should be signed. The electrical plan should be signed by a professional electrical engineer. So if you want, try to upgrade your profession, our profession, then try to take or make a design, a study related to our field, and then become a professional electrical engineer. Thank you very much, and thank you for listening. And if you think that you learned something to our video here, then try to subscribe my uh, YouTube channel. Thank you, God bless, and bye-bye.
Fire!